we want to solve the log equation, log base 1/4 of log base 2 of 3x plus 6 over x squared plus 2 is greater than 0. So first thing we have to note is the x value that we need to solve for has to be part of the domain of this function. So let's look at the domain. Basically, we want log base 2 of 3x plus 6 to be positive. Well, when does that happen? I'm going to instead treat this as an equality. And so you do 2 to both sides. 2 raised to the log base 2, and then 2 raised to the 0. That's the 2 and the log base 2 are going to cancel. You have 3x plus 6 over x squared plus 2 equals 1. Multiply both sides by x squared plus 2. Subtract by 3x and 6. And then solve here. So you get x minus 4, x plus 1. So we get x is 4 and negative 1. Now, we can figure out the domain by just plugging values. So basically, we want to see, okay, if we pick a next value, let's say negative 2, does that make this positive, this inside? Does it make log base 2 of that positive? So negative 2, well, 3 times negative 2 is negative 6, plus 6 is 0. So we're taking log base 2 of 0, which is undefined. So this is not part of the domain. If we pick a number between negative 1 and 4, say 0, that's log base 2 of 6 over 2, so that's log base 2 of 3. That is positive, so that is part of the domain. And if you pick, let's say 5, we have, let's see, 15 plus 6, that's 21 over 27. So log base 2 of 21 over 27, well, that is not going to be greater than 0. That's going to be negative. So that's not part of the domain. So the domain is going to be from negative 1 to 4. So whatever solution we get, we want to make sure it's going to be between negative 1 and 4. And that is strictly not including negative 1 and 4. Because if you plug in negative 1 or 4, it makes it equal to 0. Okay, so now to solve the inequality, we're going to treat this as an equality. So there's no more inequality for now. And then we're just going to do 1/4 to both sides. The 1/4 and log are going to cancel. We have log base 2, 3x plus 6 over x squared plus 2 equals 1. And then again we do 2 raised to both sides. The 2 and the log base 2 cancel. We have 3x plus 6 over x squared plus 2 is equal to 2. We'll multiply both sides by x squared plus 2. And then we'll subtract by 3x and 6. We'll factor this out. So this will be 2x plus 1, x minus 2. And that gives us negative 1/2 and 2. So now the next step is to draw the number line. We know that the domain is between negative 1 and 4, but not including those. And then we have these points negative 1/2 and 2. So we want to test these different regions. So keep in mind the original problem is log base 1/4, log base 2, 3x plus 6 over x squared plus 2, and you want this to be greater than 0. So the idea is now, okay, let's pick numbers in these 3 regions, and then let's plug it in and see if it works. So let's pick a number between negative 1 and negative 1/2. Let's say negative 3/4. You would plug it in, and you would see that it does work, so that it is positive. And then we pick a number between negative 1/2 and 2. Let's say 0. When you plug in 0, you see that this does not work. So this is negative, and then between 2 and 4, plug it in, let's say 3, that is positive, so that works. So then you would say the solution is between -1 and -1/2 union 2 to 4. You want to make sure you don't include -1/2 and 2 or -1 and 4. And so this is the final answer.